Alright, so we have Pranit in the classroom, and then we have Ria, Dave, Chris, Rehan, and Dhanvir. So we are going to the next unit, which is unit 7, and that is where we'll talk about the things. We'll start with the concepts on okay. We'll talk about the concepts on ratios, rates, and proportion. So this is primarily this topic is mainly to deal with problem solving in data analytics. Okay, but before we start this topic, okay, I wanted to make an announcement. Now you guys know that when I'm teaching you guys, obviously I'm taking fee, and I don't like that. So taking fee for teaching is something that I do that because that goes for for a social cause. But then what I was thinking was, how about creating some motivation for you guys? Meaning, among you all, every year I will probably pick one or two students, depending on your SAT scores. If let's say somebody learns math from me for 2 years, and then they make me proud by scoring, let's say 780, 790 in the SAT exam, I will sponsor their accommodation for 3 months. How about that? That becomes a motivation for you. And that's more like something where I'll convey that you made me proud. Because anyways I'm getting some money from you guys. Not from you guys, but from my parents. So that money will go back to you for doing a good job. Because my main motivation for teaching is to make you guys more comfortable with math, make you guys more successful with whatever knowledge I have or whatever I can learn for you. So that will associate with that same strategy. I'll make that as a public information so that more kids can join, and I'll keep on emphasizing the point that you guys, whatever you learn, make sure that you keep sharing among yourselves, because I want to build that healthy competition. I don't mind if 10 of you get 790 and I end up sponsoring your 3 months education. Not education, 3 months accommodation, and that's a good sum. My daughter is going to school college this year. I know that I have to pay $1,000 every month for her accommodation loan. What if I take part of the share and make it more comforting for your parents? Because I'm just taking money from you guys, so that goes back to you. Yeah. And this will be more like a scholarship scheme, okay? Because I have a registered company here, and this will be coming from the company. So nothing fishy, nothing behind the scene. It will be like a motivation for you guys. If you do good in your SAT exam, if you get 790, 800 in math alone, that makes me proud, and you get a scholarship from me. That's the motivation I'm trying to create for you guys. And more the number, more pride for me. Okay. All right. That was more of a message for you guys. I'll anyways make a public announcement so that more kids get to know about it. We build a lot of competition among ourselves. Competition as in healthy competition in a more playful way, and we'll see. Yep. Any questions so far with whatever blabbering I was doing? No questions? Just questions? You guys are very shy, even if you guys are much younger than me. Okay, alright. So let's not worry about that. I'll pass on this message back to the parents, and this will go in a public domain. So we'll figure out what to do. But net for you guys, the message is, do math, enjoy it, because you and I are working on the same goal of each one of you working on scoring a near perfect score in math. That is the moment that I'm working towards. Alright? Okay, so let's do a quick roll call. We have Aryan, Dave, Dhanvin, Chris, Neil, Rehan, Ria, and Sarah. So we are starting a fresh unit that is on data analytics and problem solving. And you'll find that there are a lot of concepts that you guys are already aware of. We are starting with ratio, proportion, and rates. That is the topic we are starting with. And everybody must be thinking that, okay, this is something that we have learned when we had just gotten past that diaper stage. meaning when you guys were all babies, right? I mean, you would have learned in third or fourth grade. Now we are in the high school. Why we are even talking about it? But fact is, these are some of the topics which will be a scoring topic, and there's a lot of discussion around the concepts that will come into play when you are dealing with word problems. So that is what we'll deal with today. Role ratio and rates. We will just do a cursory glance of that. Do a recap with respect to understanding the basic concept. If there's no gap, we'll just redo that, and then we'll look at some problems, the word problems, the cryptic, the scary looking word problems, and see how this concept that we know is going to help us getting those questions solved. Yeah. Any questions so far? No? Hey Vishal. All right. So let's look at these three terms: ratio, proportion, and rates. Who can tell me in the simplest form what these are? Try teaching me. Okay, let's start with ratio. Who can explain what exactly is ratio in the simplest possible form? Yes, Dave.
A ratio could be like a comparison of how many objects there are. Like in a bowl, the ratio of apple to oranges is 2 to 3.
Okay. Okay. How about you, Chris? What is your definition?
It's like a comparison between two objects, like between like the number of each object or something like that.
Okay. Any other definition? Anything else where you want to make it more creative or simpler? No. So I'll go with what Dave and Chris are saying. I will make it even simpler by saying it's just a comparison of two numbers. I'll not even care about the objects part of it. Because when you talk about objects, people will start thinking about Java programming, object-oriented programming. That is complicated. Let's not go there. I'm not saying that I'm not done programming in object-oriented concepts, but I'm saying we'll keep it simple. So when you are talking about ratio, essentially it's a way to compare two numbers. Now, 3 versus 6. I'm talking about ratio right now, okay? So, if I'm saying 3 versus 6, 3 is half of 6, 6 is 2 times of 3, that we all know. And that is exactly what ratio tells us. 3 is to 6, when you're comparing these two numbers, 3 is to 6, this tells us 3 is half of 6. Similarly, when you compare 6 against 3, then you know that 6 is 2 times of 3. So, ratio is always a method to compare one number against the other number. So, the value of the ratio will be determined based on which number you are considering as a base and then comparing that with other number. So, that's why, and if you look at it mathematically, always say which number you are comparing. That is always the top. That is the first thing you have to consider. Against which number, that goes as second number or at the bottom. And then, whatever calculation you have to do, that you guys know. So fine, you will say that, okay, so you wasted 10 minutes talking about it, and that's fine. I have that luxury to waste your 10 minutes because today is my birthday. Thank you. Now, second one, so we talked about ratio, so that you guys, anyways know, we are just doing a recap of that. Now, second one is proportion. What is proportion?
Like 1 cup of rice, you use 2 cups of water, something like that.
Okay. Anybody can define proportion? I know ratio, why do I need to learn this? Yes, Chris.
A proportion is more like comparing kind of amounts of something, right? Instead of more like actual values.
Right. No, see, the most stupid question that I have for you guys is, I know the ratio. Why you need proportion? So, okay, let me break the ice. Proportion is a scenario. Yeah, you're saying something? Yeah.
Is using proportions you can scale up or scale down comparisons.
Right. So basically, when you look at proportion, you're talking about two matching ratios. Okay. Now look at the situation. If I say, let's say, anybody who is interested in baking, right? I'll say, okay, fine. If I'm making a cake, I'll probably put the flour, and sugar in 4:1 ratio. Okay, meaning if I'm taking 4 cups of flour, 1 cup of sugar, this is the proportion in which I'm going to use. So if I'm making a bigger cake, I'm taking probably 8 cups of flour and 2 cups of sugar. Between this small cake and the big cake, what is that you see? It is 4:1 here, this is the ratio. It is 8:2 here, this is the ratio, which eventually becomes 4:1. So proportion is all about matching ratios. When you're talking about proportion, your base number and the number against which you're comparing, that could change, but you're always ensuring that your ratio remains the same. So when you're talking about proportion, you're essentially ensuring that your ratio remains the same. Now, if you want to make a tinier cake, like this smaller cake, you'll probably put 4 grams of flour and 1 gram of sugar, versus you making a mega cake which is 1000 kilograms in weight. You'll probably put 400 kilograms of 800 kilograms of flour and 200 kilograms of sugar. What you're trying to ensure here is your ratio remains the same. So proportion is nothing but, again, other way of comparing numbers where you have a predefined ratio that doesn't change. Depending on how big or small quantity you are dealing with, your ratio will remain the same throughout. So that's one thing. I mean, I was also, I'll just be honest with you guys. I was always thinking that now why do we have to worry about proportion when we know ratio? And proportion also we do the same thing. So proportion is an extension of ratio where you're saying, okay, fine, I have defined my ratio, and every proportion that I talk about will ensure the same ratio. So proportion is a scenario when you are ensuring the same ratio, and then you are going with it, right? Let's say if the school district had decided that in every class we'll have, if 80% of the students focusing on studies and 20% on sports, regardless of how big or small the class size is, the ratio of the students doing studies versus sports will remain the same. If it's a 5-student class, 4 kids will do studies, 1 person will do sports. If it's a 500 students class, 400 students will do studies, 100 students will do sports. That's how it is. So the proportion is, this is the proportion for bigger class, this is the proportion for smaller class. What is fixed here is the ratio. Is that a good way of relating these two? Yeah? Because I had my own doubts with this, okay? I used to think or grapple with this, saying, okay, why do I need to worry about proportion? It becomes more like a story. And whenever we talk about proportion, we'll talk about, okay, making cake or making curry, making something, and then we'll say, okay, fine. But that is what we have in ratio also. So it just says proportion is the actual value which just ensures the ratio remains the same. Is everybody okay with that so far?
Yeah.
Okay. Now, then comes the rate. Now, this is another thing. What will be rate?
Rate is like the amount per unit, or like something like a ratio per unit, like 1 mile, 1 gallon per mile,
Mm-hmm.
something like that.
Okay. Let's see what Chris says. Yeah, Chris.
A rate is how like quickly something changes, almost.
Right. Now let me give you guys even a simpler definition of it. Rate, we always talk about rate, right? I mean, in terms of price, $2 per pound, 70 miles per hour, right? 2 gallons per square kilometer, something like that, right? So here, let's take some example. Let's talk about speed. We say, okay, 70 miles per hour. This is the designated speed. If you go at 90 miles per hour, there's uncle waiting for you. Yeah? Now, so keep the uncle aside. Uncle has nothing to do in this math. Here, or I'll say I drink 10 glasses of water per day. Okay? Here, look at this ratio. I'm saying 10 by 20. And here, let's say this is the ratio between the two numbers that I'm comparing. Or if I'm talking about proportion, then I'm talking about 2 cups per 2 cups versus 1 cup, 4 cups versus 2 cups, some 2 numbers. Here, if you look at just the optic part of it, don't think too much, just look at the optic part of it. What you see here is, in this case there was no unit. Or if the unit was there, it was probably the same. If I say, okay, this is Praneeth's age, this is my age, no, that is not right. Yeah? So, this is also years, this is also years. Okay? What is happening is my units are the same between the two numbers I am comparing. Here, you will see that there are 2 different units. When you are talking about rate, the units are different. You will not say, I drink 10 glasses per glass. You are saying, I am drinking 10 glasses of water per day. So here, number of glasses is a unit for measuring volume, and per day is a unit for measuring time. So units are different. So rate, in case of rates, you are essentially always comparing one quantity with some units against a different unit. If I, let's say, make it look like a ratio, I'll say 20 miles per 3 hour. So this is a ratio, but my units are still different. Yeah? So that's a fundamental difference that you will see between ratio, proportion and rates. Ratio and proportions, they don't have units, or if they have the same unit. But rates are always measured against a different unit. Is that differentiation acceptable to everybody?
Yeah.
Yeah? Alright. So this will be our going in position. Now, there is nothing that I want to teach you guys right now. Because today is my birthday. No. Again, I feel really happy about my birthday anymore. Because now if anybody asks me how old are you, that's one of the difficult questions to answer. And I don't know how to solve that problem. So coming back to the agenda for today, let's look at some problems. Because these concepts you guys know. Even if I waste another 30 more minutes, there's nothing new that I'll be teaching. Let's look at the concepts that we know and how do we apply those concepts and see how comfortably are we able to do it. Let's start with some easy ones. The first question says 9 markers cost $11.5. How much would 7 markers cost? Does anybody want to solve this? 9 markers cost 11.5. 11.5. How much would 7 markers cost? You want to solve it? Okay, let me put the second question also. This is the first one. And this is just like a jump start, okay? Once we look at this one, then we'll go to Excel problems. Second one says 7 apples cost $5. How many apples can I buy with $8? Third one says a cake recipe for 5 people requires 2 eggs. Cake recipe for 5 people requires 2 eggs. How many eggs do we need for 15%? 15%, how many eggs? So, see, while these questions will look very stupid, very underrated, very, I'll not use the term derogatory, but very undervalued for you guys. But there is a very important message, there is a very important trick hidden in this, which I want to talk about, and that's the reason why I have put these questions. I would want you guys to solve it, and I'll be very happy if one of you go wrong. No, I'm just kidding. I'm not willing, I'm not hoping that anybody goes wrong, but I'm still looking for an opportunity where I give you guys a standard method here. Are you guys doing it? Alright. Yes, Vishal.
For the first one, I got approximately $12.6.
$12.6. 9 markers come for 11.5. How much 7 markers would come for?
Wait, my bad. I was wrong.
Okay. Okay. Do you want to talk about the second and third one, Vishal? Okay. Let's go to Chris. How
For
much
the
is
second one, I got 8.96.
8.96.
No, I mean, for the first one, I got 8.96.
Okay. How about the second one?
I didn't do it.
Okay. Yeah, Chris, tell me.
Yeah, for the first one, I got 8.95, not 8.96.
Okay, that's fine.
Same thing.
How about second one?
Second one, I got, one sec.
First one I got 8.97.
Okay.
For the second one, I got 11.2.
Okay.
I also got 11.2 for that one.
How about this one?
And then I got 6 eggs.
Okay.
Yeah, same.
Yeah.
Same.
Yeah. How about you, Vita?
I got 6.
You got 6 for this one. How about this one?
I got 11.2.
Okay, same.
I got 8.9. 444, so it just rounds up to 8.95.
Okay. All right. Everybody else. Rehan, Neil, Sarah. Arif. You got the same answers. We'll see. Okay, so now coming back to the point that I was making, that am I really wanting to waste everybody's time? Probably not. That's the last thing I would want to do. When it comes to math, you take me for a social studies class, I might end up doing so. I'm not very much fond of social studies, and that's one subject I literally ignored in my school days, big time. But I'm not trying to influence anybody, okay? I mean, it's a very nice subject. I still got a good marks only because I got scolding from my aunt with whom I used to stay. It was the last exam of my board when I was done with everything else, and I thought, okay, social studies, that number doesn't count for me any which way. So I was having fun. Then my aunt scolded me in front of the whole family, and I got really upset about that. Okay, fine. People don't care about me. I'll just go and study. Next 2 days I disappeared. I hid in a corner and I was studying. Only 2 days in my entire school I studied. I still got decent marks. So I wish I could have studied little more. But yeah, coming back to the point, any subject is not good or bad. It just depends on how much you study that. Coming back to this particular problem here. What I was trying to convey here was this. If you have problems like this, you guys would have solved hundreds or thousands of problems like this. But I'm just trying to add some method to the madness. So Vishal, if you want to explain this to me, okay, I'm just handpicking you, okay. If you have to explain this to me, these three problems, what was there the common approach that you thought, or how did you go about it? Just give me a breakdown.
I just like first, so since there's 9 equals 11.5, I just thought the easiest way to make it is to make it 1. 1 is equal to how much? Plus then all I had to do is multiply 1 by 7 and the other one by 7 to get the answer.
Okay.
So like I just simplified it to the 1 so that it becomes easier.
Okay. How about you, Chris?
Yeah, I followed the same method. I just wanted to get it to how much does 1 marker cost? So I did 11.5 divided by 9, and then I just multiplied by 7.
Okay.
I know this would, the two ratios would be equal in ratio wise, so I just found out what times 9 equals 7. I got like 0.7 repeating.
Wait,
So
was
I
that
think-
11.5 or 11.9?
11.5.
Oh, okay.
Okay.
So I got 0.7 repeating, and since we're talking about money, I rounded to the second decimal place because it's money, and I got then I multiplied 11.5 by 0.78.
Okay. So now let me open my cards. Here, when I'm dealing with this situation like this, these are not math, these are stories that we deal with every day, right? And the deals that we come across. This is one deal. This says 9 marker comes for this much, how much 7 markers would come for? It's like me, like a dad going to a store where my daughter has asked me to buy 7 markers, and I see that, okay, in the store it says 9 markers is worth this much, find it out by yourself. So, or here in this case, 7 apples come for this many dollars. How many apples will come for $8? Another scenario. This is the rate I know, and when I check my wallet, I found, okay, I have $8, and this is the only thing I'm going to buy. How many apples I can buy? 5. If I'm baking a cake for 5 people, it needs 2 eggs. If I have 15 guests coming, how many eggs I need to buy? These are real life scenarios. So when I'm talking about this kind of problems, if you look at these story elements, you have something known, one situation, this is known, this is known. This situation, this is known, this is not known. This situation again, this is known, this is not known. This is not known and this is known. In this scenario, if you assume that there is an equal to sign here somewhere. Now you look at this situation. This is known, this is also known. This is known, this is not known. Remember one thing, what you have to find out will be on the right hand side. That's the first thing. Okay? So when you have a question like this, first thing you'll do, I mean again like a baby, okay? Don't make it, don't give much value to these kind of problems. Make them small, easy. So whatever I have to find, what will be this? For this, what will be this? Right? So whatever you have to do calculation for, that has to be on this side, on the right hand side. So if you look at this, you have something known to you, both the sides known. This is not known, this is not known. Okay, this is on the right hand side. So this position is right. In this case, this is known, this side is not known. But this position doesn't seem to be right. Let me flip it. $8 will be, I'll get how many apples? Yeah? So if I'm flipping this one, I will flip this guy also. $5, I'm getting whatever it was, 7, right? 7 apples. So this story, these two stories have a flow. This story also has a flow. Both the things are known. This is known, this is not known. Now look at why. Now let's read this story. 9 markers come for $11. 7 markers will come for how many dollars? $5, with $5 you can buy 7 apples. With $8 you can buy how many apples? With 5 people, for 5 people you need 2 eggs for making the cake. For 15 people, how many eggs you need? My story is in a sequence. Now, in all this situation, I have to just add one more line to my story. 8 markers come for this. How much dollar one marker will come for? And then whatever is the value, I'll multiply that by 7. That will be my answer. $5 can help me buy 7 apples. $1 will help me buy how many apples? I'll find that out. Okay? And then multiply that by 8. I get my answer. 5 people needs 2 eggs to make the cake. 1 person, how many eggs will need? And multiply that by 15, that will be my answer. Once I get some value, whether I have to multiply by 15, whether I have to multiply by 8, whether I have to multiply by 7, that's the easiest thing I can do. Yeah? So my whole logic or calculation lies here to find out the value per unit. If 1 person can eat 20 mangoes, how many 5 people can eat? You multiply 20 by 5. If 1 person needs $20 to survive a day, how many dollars you would need for 20 people? Multiply 20 by 20. Yeah? If you know the unit price, it's everything that we do in our life, it revolves around the unit price. $20 per pound to buy something. $2 per gallon. $3 per square meter. Everything is in units. So if you can derive the value for the unit, your mystery becomes much easier to deal with. Same thing here. Now look at the situation. I am going to do that in the lamest possible way for solving this problem. 7 marker comes for $11.5. 9 marker comes for $11.5. 1 marker will come for how much? 9 marker comes for this much. 1 will be this much divided by 9. 11.5 divided by 9. If I have to find for 7, whatever is my unit value, okay, let me not go there. Let it be. 1 unit value I have found. Here in this case, $5 you can buy 7 apples. How much you can buy for $1? Whatever you spend for 7, divide by that number. That is your unit price. 5 people, you need 2 eggs. For 1 person, you need 2 by 5. This guy just crosses the equal to sign. See, it goes down. Whenever you are talking about a movement across the equal to sign, you are talking this way, right? So here, 5 goes this way. Similarly here, this 5 came here. Here 9 came here. When you are talking about 1, it's 9 to 1, right? So you are getting rid of 9, making the 9 go down. Now in all the scenario you got for 1 value. For unit, you got the unit price. Or unit for value for the unit. Now for 15, whatever you got, 2 by 5 multiply by 15. You got for 1 you got 7 by 5. For 8 how much you have to find? Whatever is your value for the unit, you multiply that by 8. Here you got the price for 1 marker. You have to find for 7, multiply that by 7. So this is more of a very monotonous, simple step-by-step process for doing the calculation. Whenever you're dealing with this kind of a thing, right? The basics of algebra, your intention is you have to always look at a very simplified, broken down approach where you say, okay, fine, whatever I have to find has to be on this side. Let me stitch my story. Let me not think too much. What I have to find has to be on this side. So that is how I'll reconstruct my story. Find out the value for the unit, multiply that with whatever I'm trying to find for. Same thing here. Whatever I have to find has to be on the right hand side. Find out the value for the unit, multiply that with the thing that I am trying to find for. Repeatedly dust. Yeah. This will make sure if you know what you have to find, if you figure out the value for the unit, there is nothing complicated about it. And you will not think whether it's going to be 11.95 by 9, 11.5 by 9 or 9 by 11.5. That confusion will not be there. Because it's a very simple thing. It's a very simple, boring, annoying step if you look at it. If I take the first example, 9 markers come for 11.5. 9 is nothing but 9 into 1. 9 markers value is equal to 11.5. So 9 into 1 is 11.5. If I want to find out the price of one marker, I have to get rid of 9. And how it travels, it goes this way. It goes downwards like a cross. So 11.5 divided by 9. Now I got the unit. If I have to find for 7, that means 7 is 7 to 1. So I am multiplying 7 this side, I have to multiply 7 this side also. Done. So always we'll stay in the lookout for making things simpler. That's what we are doing now. And this was just like a jump start for more interesting word problems that we'll come across. So let's look at it. But before I go there, anybody having any question with whatever we have discussed, anything that is making you feel overwhelmed or you are perplexed with respect to what I'm talking about? No questions? Dhanvin was the first one to say so. Thank you so much. Let's see if anybody has any doubt. It's okay. It's okay to have doubts. It's not okay to not have doubt, because you will have doubt only when you think. Okay? So I'm assuming that I have everybody's approval for going forward with the next question. Let's look at the next one. So next question is a little tiring one. It is a verbose question. So let me read it for you guys. And remember this. Our approach will be same. Whoever wins the medal in the race depends on who ran the best. Read, analyze, and then make it. Let's follow this. Erika plans to purchase seed to plant grass in a large field. Erika plans to purchase seed to plant grass in a large field. She has a map of the region and calculate the area of the region on paper to be 100 centimeters. Let me Erika plans to purchase seed to plant grass in a large field. She has a map of the region and calculates the area of the region on paper to be 180 centimeters square. The scale on the map shows that 1 centimeter equal to 20 feet. I'm just writing the numbers so that you don't have to memorize them. If Erika plans to cover every 400 square feet with 1 pound of seed, approximately how many pounds of seed will she need to cover the entire field? Now let me repeat the question. Erika plans to purchase a seed to plant grass in a large field. Let's say this is a field. I don't know whether this is a square, rectangle, whatever. Plans to purchase seed to plant grass in the field, okay? She has a map of the region and calculates the area of the region on paper to be 100 centimeters square. This is the area that she has found out. The scale on the map shows that 1 centimeter equal to 20 feet. So she has a map, okay? The area of the map. So field is somewhere else. This is like I am drawing it on the board, okay? The area of the map that I have drawn here, the area of the map is 180 centimeters square. So this is the area of the map on the board. And the scale on the map shows that 1 centimeter equal to 20 feet. If Erika plans to cover 400 feet square, if she wants to cover, if she plans to cover every 400 feet square with 1 pound of seed, this much with 1 pound of seed, 1 lb. Approximately how many pounds of seed will she need to cover the entire field? So I talked about a lot of things. Let me, since I read this so many times, so I kind of remember this. Okay. It says that Erika plans to seed grass in a field. Okay, and she has a map of the field. And the area of this map is this much. Now, whenever you see a map, right, take any map, you will see that it gives you the scale. The scale of the map says 1 centimeter equal to 20 feet. Okay? So, I'm repeating the same thing here 2 times. If she plans to seed every 400 feet square with 1 pound of seed, how many pounds of seed she would need? I want you guys to give it a shot and then, yep, yeah, dear.
I have the answer.
Okay. How much it is?
9 pounds.
9 pounds. I will come back to you better to understand how did you do it, but I will let everybody else give it a try. You also got 9 pounds? Okay. You got 9 pounds. How about you, Dhanvin?
We did say 400 feet squared is equal to how many lb?
1 pound. So basically what it says is she would need 1 pound of seed for every 400 feet square. So the question is how many, with all this information that we have, how many pounds of seed she would need to plant the entire region. Yeah?
I got 5.
I'm sorry?
I got 5.
You got 5? Okay. That's okay. We'll see. I mean, I don't know the answer yet. I have to solve it once you guys ask me to do so. So let's see. How about you, Rehan, Sarah, Neil? Aryan? Chris, you got 9, right?
I got 9 now, but I didn't say it. But yeah.
Okay. So Ria also got 9. Yeah?
Yeah.
Okay. So Pranit also got 9. So let's see how much I am getting here. So again, same approach. I read the question so many times. From the question I found that Erika is trying to plant grass in a field. And she has area of the field, which is 180 centimeters square. So, and other things that she said, the question says is, every centimeter is equal to 20 feet square. So here, so from this one, I have to find out what is the actual area of the field. And then I'm told that 400 feet square requires 1 pound of seed. Okay, fine. So now from this one, this is my source of information which will tell me how big the field is. And 180 centimeters square is the area of the map, and I am told that 1 centimeter is equal to 20 feet. So let's, and here also I need in feet. So let's convert everything into feet. 180 centimeters square. Now I am told that 1 centimeter or 20 feet. So I can write this as 1 centimeter into 1 centimeter. That is how it became 180 into 1 into 1 is 1 and centimeter square. Now every 1 centimeter replaced with 20 feet. 180 into 20 feet into 20 feet. It became 180 into 20 into 20 is 400 feet into feet is feet square. Okay, so this is giving me this thing 18 4 is 72 and 3 zeros. This is my total area. Now, every 400 feet square needs 1 pound. So what I will do is I will break this down. 72,000. See, I'm not applying any intelligence here. I'm just trying to get 400 feet square. 400 feet square I will take out. So 400 feet square. Okay. What did I do? Yeah, okay. Yeah, that's fine. So why do I have to again do the same thing? 400 feet square into 180, right? So this is nothing but 180 into 400 feet square. This 400 feet square needs 1 pound of this thing. How many pounds I need? 180. Let me see if that was one of the options in the question or not. Otherwise, I might have gone wrong completely. Nope, that was one of the answer. Now, I might be wrong, or everybody might be wrong. But let's revise, let's review, okay? And let me first read the question one more time, okay? Because any question, anybody could go wrong. I'm just reading it one more time, just to make sure that before I give you guys my last punchline, let me make sure that this is understood correctly by me also. Erika plans to purchase seed to plant grass in a large field. Okay. She has a map of the region and calculates the area of the region to be 180 centimeters square. Okay, this is 180 centimeters square. Okay. The scale on the map shows that 1 centimeter equal to 20 feet. Erika plans to cover every 400 feet square with 1 pound of seed. Approximately how many pounds of seed will she need to cover the same field? Yeah. Now, first of all, who all wants to take me head on and say, sir, this is wrong? I mean, no grudges. I'm just playfully asking you guys. I love arguing with my students, so that's what I'm asking. No. Now let me put it this way. So when you guys got 9 pound, let me first decode this one more time, so that then we can discuss. This question says that she has to put seeds in the plant, in the area, in a field, and only information that she has is this map, which has the area of 180 centimeters square. Be it square, be it rectangle, be it triangle, be it a circle, I don't care right now. I just know the area, right? And I have to cover this area. But then this is just a map. This is on a A4 sheet maybe. But the actual field is different. And say there is a scale. This scale says that every centimeter on this map is equal to 20 feet. So that tells me that, okay, if I want to derive the size of the field, that means it is 180 centimeters square, or centimeter square is nothing but 180 into centimeter square is nothing but centimeter into centimeter, right? Or 1 centimeter into 1 centimeter. And I have the scale here. I'll replace every 1 centimeter with 20 feet. Yeah. So this tells me what is the actual area of my field. Interestingly, 20 feet into 20 feet, 180 into 20 into 20 is 400. Feet into feet is feet square. and here I have been told that 400 feet square area needs 1 pound of seed.